Welcome back. We're continuing with solving inequalities. In our last video, we looked at the addition and subtraction properties of inequality, and we were finding what region of the graph made a true statement. So in this particular graph, we found that every value to the right of 6, not including 6, so 6.000001 will make a true statement, but 6 will not. So every value to the right of 6 will make a true statement here. We're going to continue on looking at some other situations. And we want to look at the multiplication property of inequality. The multiplication property of equality was really important for solving equations, and the multiplication property of inequality is going to be similarly important. Now, there's a key difference between the multiplication property of equality and the multiplication property of inequality, and that has to do with what we're multiplying by. When the value we are multiplying by is a positive number, okay? So if it's a positive number, nothing changes. So if A is greater than B and I multiply it by a positive number, like say 4, I multiply both sides by 4, A times C is still greater than B times C. Or if A was less than B, then A times C is still less than B times C. But what happens when we multiply by a negative number is that my inequality symbol is going to change directions in order to make a true statement. So let's look at an example showing that. So if I start with 2 is less than 5, and I multiply each side by 3, I now have 2 times 3 is less than 3 times 5. 2 times 3 is 6. 3 times 5 is 15. This is a true statement. We are making true statements. In order to make a true statement, if I multiply by a negative number, so I'm still starting with 2 is less than 5. I now have 2 times negative 3 and 5 times negative 3. So I've multiplied by a negative number. Now I have negative 6 and negative 15, and I want to look at those. Negative 15 is now to the left of negative 6. So negative 15 is now less than negative 6. So negative 6 is greater than negative 15. So what happens when I multiply both sides by a negative number is I have to change my inequality symbol. This is really important. When you multiply both sides of an inequality by a negative number, you must change the direction of the inequality symbol to make a true statement. Always, every time. All right. Now that we've looked at the multiplication property of inequality, I'll leave that there. We're going to look at the division property of inequality. So for any real numbers A, B, and C, if C is positive, and I divide both sides of my inequality by C, nothing changes. So if A is greater than B and I divide both sides by C, and it's a positive number, we're all good. But similar to my multiplication property of inequality, when I divide by a negative number, my inequality symbol is going to change directions. And we're going to look at that really quickly here. So a similar example to that last one, if 8 is greater than 6 and I divide both sides by positive 2, I get 4 and 3. My inequality symbol to make this statement true, to make a true statement here, is going to stay the same. So my inequality symbol doesn't change if I divide by a positive number. But if I divide by a negative number, 8 is greater than 6. I divide both sides by negative 2. 8 divided by negative 2 is negative 4. 6 divided by negative 2 is negative 3. Negative 3, negative 4. Negative 3 is actually greater than negative 4. So my inequality symbol flips directions. So anytime you multiply or divide both sides of an inequality by a negative number, you must flip the direction of the inequality symbol to make a true statement. Let's look at how we might use this to solve a simple inequality. All right, so I've got 4x is greater than or equal to negative 24. To solve this inequality, I need to divide both sides by 4. 4 is a positive number, so I don't need to worry about changing my inequality symbol. This becomes x is greater than or equal to negative 6. Okay, so here's 0, here's negative 6. If I go back to my cheat sheet here, I have a greater than or equal to symbol, so I'm going to have a closed circle at 6. And if I check x is equal to 0 in my original inequality, 4 times 0 is greater than or equal to negative 24. That's a true statement, so I'm going to shade that side. So that means that every value, including negative 6, all the way up to positive infinity, will make this statement true. When I look at my next, negative 9x is greater than negative 81, I need to divide both sides of my inequality by negative 9. I'm dividing by a negative value, so I have to remember to flip the direction of my inequality. Negative 81 divided by negative 9 is positive 9. So I put 0 on here and 9. If I go back to my cheat sheet, this is a less than, so it's going to have an open circle. If I check 0, x equals 0, I'm going to go ahead and check that. And in my original, negative 9 times 0 is greater than negative 81. 0 is greater than negative 81 is true, so I'm going to shade the side that includes 0. So that's what it looks like there.